The general conviction among most experts is that the speculation of how things came to be stays the major clarification for the early times of the universe. This hypothesis joins the development of stars, planets, and, in this way, forward life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang, it offers an illuminating assessment concerning what could have occurred at first. The universe was thick in a short space, more thick than a pinhead, with particles thickly packed. From this moment, a monster effect of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the fanning out of tremendous history. In any event, in reasonable information, it has set off creating idiosyncrasies with the assumptions of this hypothesis. At the point when NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, experts assessed that its insight would confirm the hypothesis of the universe's starting point. Sadly, after only 1 year in space, the telescope stunned experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's dazzling capabilities have revealed innumerable universes going as far back to a time so old that it challenges how we could interpret the universe's beginnings. This disclosure has started an intense examination concerning what existed before the Big Bang. One crucial point in time in this mission happened when cosmologist Rohan Natu, working with data from the telescope, unexpectedly found a system from just a brief time after the Big Bang, making it the most distant universe ever seen. Natu's discovery sent shockwaves through established experts, highlighting the amazing abilities of the James Webb Telescope. Its huge potential to change our perspective on the universe has barely begun, promising to reveal amazing insights into the earliest seasons of the universe's existence. This period, scarcely focused on in advance, holds the key to getting a handle on the development of the first stars and galaxies. The telescope's revelations have clashed with principal hypotheses, uncovering systems with attributes outflanking past assumptions. This exceptional flood of early universes has sparked a storm of scientific inquiry, testing experts to align these revelations with existing theories. As analysts uncover these exposures, they face key questions about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's advantages, which are clear, it is viewed as 1.5 million kilometers away from Earth, shielded from infinite interference, and cooled to approach absolute zero by its tennis court-sized sun shield. The telescope incorporates a huge piece mirror and stunningly fragile instruments, intended to reveal details of the early universe previously secret. This period, known as the cosmic dawn, occurred around 200 to 300 million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of great inquiry, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's perspective on galaxies from the cosmic dawn presents a novel opportunity for cosmologists to test how they may interpret these complex components. By studying these ancient systems, specialists can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. Initially, the telescope was expected to notice only a few weak and small galaxies in its pilot studies. However, the reality has far exceeded these expectations. The telescope's early images of the distant universe uncovered an abundance of galaxies with ages, sizes, and brightness levels that defied all predictions. This shocking surge of early galaxies has begun a race among space researchers to establish new standard records for the earliest known massive systems, with new relations emerging constantly, leaving ordinary specialists in awe. Following the James Webb Telescope's exposures, subject matter experts and observers have raced to study the presence of these shockingly advanced early universes. Some hypothesized that errors in the telescope's interpretation of tremendous observations could be responsible for these alarming discoveries. That said, the consensus remains that these discoveries represent a paradigm shift in how we could interpret the early universe and offer exciting glimpses into the potential for immense advancement. The new discoveries from the James Webb Space Telescope about galaxies have raised significant questions regarding the nature of the universe and tested the assumptions of standard cosmological models. While some specialists are examining whether these insights can be accommodated with existing theories, others suggest that they may be the first signs that the universe is far more complicated and puzzling than previously imagined. The pivotal question in play is our fundamental understanding of how the universe we know emerged from primordial chaos. The early revelations of the JWST could reshape our core ideas of cosmic history, revealing insights not just on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFan, Senior Scientist for Science and Exploration at the European Space Agency, puts it, you build these machines not to confirm hypotheses, but to break them. You just have no idea how it will break. The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with imagining what might come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much deeper into the universe. This ability is critical for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive, cold star-like mirror, the JWST became the premier instrument for uncovering the mysteries of the cosmic dawn. The need for the JWST was highlighted in 1995, when the Hubble Deep Field Observation uncovered countless galaxies in what was once thought to be a blank patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of examining far deeper into cosmic history. After 20 long years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early initiatives like the Early Release Science Program and the General Observing Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far surpassed them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge conventional cosmological assumptions. These stunning revelations highlight the importance of pushing the limits of scientific inquiry and showcase the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to explore JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began rolling in from the JWST, cosmologists eagerly anticipated the results. Many had been setting up their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which typically takes months, researchers chose to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new type of peer review to take place through online platforms like Twitter, where established experts could immediately discuss findings. Rohan Natu described this process as science by press release, and the subsequent storm of discussion was both intense and surprising. However, there were concerns about the potential downsides of this rapid spread of results. Klaus Pontypool, a JWST project scientist at STSCI, warned that while the quick sharing of results facilitated rapid dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most experts is that the hypothesis of how things came to be remains the primary explanation for the early times of the universe. This hypothesis joins the development of stars, planets, and life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang, it offers a convincing explanation for what might have happened at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a gigantic explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history. However, changes in scientific knowledge have led to anomalies with the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, researchers estimated that its observations would support the hypothesis of the universe's beginning. Unfortunately, after just 1 year in space, the telescope baffled experts with its ability to peer deeply into the universe's past. The James Webb Space Telescope's astonishing abilities have uncovered galaxies dating back to such ancient times that they challenge how we might interpret the universe's beginnings. This discovery has sparked a serious examination of what could have existed before the Big Bang.